All right, grabbing the paper from our substitute, we're going to start here by having you look at what I've provided you at the top of your assignment. You are going to be describing in words on paper without graphing something in decimals, without graphing it on a calculator, what is happening. So as I go from this basic parent function, an absolute value function, to this, we're going to describe what happens. Does it move left? Does it move it right? Does it open up faster, called stretched? Is it pushed down and opens up slower, called compressed? We're going to talk about all of that. What I want you to do is press pause, and on your paper, on the top portion, please write these words in underneath each of the lines. Come back and press play once you've done so. Let's jump now, hopefully you've had a chance to write this down, and let's talk about what this looks like. So this is the most basic parent function. It's an absolute value function. Last week we talked about when you have this function, and I'm going to copy and paste this, you're simply watching, and if on the inside I ever put a value like -4, remember it lies to us. We can see how it went from red to blue by shifting 4 places to the right. Just like if I made that a +3, we would shift 3 places to the left. So the inside lies to us. Now, and behind it, if we do a number like -4, it takes it vertically and it shifts it down. And it does so just as you would assume. So the back side of this tells the truth, the inside lies to us. We learned that last week. So here if I do a +2, it shifts everything up to it. Those are all things we learned about. Something else we're going to talk about today is the word stretch and compress. If it stretches, it moves up at a faster rate. So right now there's a 1 on the outside. If I change it and make it anything greater than 1, we use the word stretch. And I'll give you an example. If I put a 5 there, do you see how from red to blue, how it increases at a faster rate? It rises up faster. We use the word stretch. So in this case, we would say the function is stretched by a factor of, and whatever number's in front is what we use, by a factor of 5. Here, the function is stretched by a factor of 3. Here, the function is stretched by a factor of 1.3. Or the function is stretched by a factor of 2.6. Anything greater than 1, whether it's a decimal or a fraction or a whole number, we always say stretched, and we say by a factor of whatever value is in front. Now, if this number in front is anything between 0 and 1, like 0.1, for instance, we can see it's compressed or it's flattened out. We use the word compressed. 0.3, it's compressed by a factor of 0.3. 0.99 is still less than 1. It's compressed by a factor of 0.9 in this case. All right. Now, if we take and make the number in front with a negative sign, like a -3, this is actually 2 different things. And I'm going to put parentheses around those so you can see that. That's one part, and here's the other part, and that's often confusing for students. So if I gave you this, whoops, sorry there. Oh, let me go back up here. If I gave you this and I changed this to a -3, there's a couple different things we have to describe here. The negative sign is separate from the 3. So let me see if I can cover up this negative sign. I'm just going to highlight it. So here we can see that if I take away the negative, we can see that it definitely stretches, right? 3 is greater than 1. So we would say that the function stretches by a factor of 3. But what about that negative sign? The negative sign makes it flip across the x-axis, and the word we use is reflect across the x-axis. We're going to get started, and we're going to practice a few problems together. All right, and you are welcome to take notes. If you find this at all difficult, I would definitely replay this video at a slower pace. Okay, the order in which you do these does not matter. In fact, I will tell you for your work how many dots you're going to have for each one of your upcoming problems. So this is not a homework problem. It's similar to a homework problem. The first thing I'm going to start with is I know that the inside lies to me and the back side is going to tell me the truth. So I'm going to come up here. This describes a horizontal shift. So I would write down in words. I'll let you do that. Word for word, you would write down the function is horizontally shifted to the, okay, it lies to us. So to the left 5 units. This is what you write down in this space. The function is horizontally shifted to the left 5 units. Okay. Okay, I've got this part done. I'm going to lightly cross it out. Let's do the next part. This describes a vertical shift, anything in back of that absolute value. So the function is shifted down. It tells the truth. The function is shifted down 3 units. We don't say -3. The negative sign is associated with the word down. The function is shifted down 3 units. Done with this. Now, we need to decide, is a value out front, if one exists, is it greater than 1 or less than 1? If you don't know, type it up in your calculator. Okay, 3/2 is the same as 1.5. Anything greater than 1 is considered to be a stretch. So I'm going to write, if a number is greater than 1, it's a stretch. If a number is less than 1 and greater than 0, it's considered to be compressed. All right. Since 3/2 is greater than 1, my third dot would be the function is stretched by a factor of 3/2. Or you could write 1.5. Let's write our next example about translations. Let's start on the inside. The inside side always lies to us and it says to go left or right, which is horizontal. So I'm going to start with this first dot here, and I would write down the function is horizontally shifted to the, it lies to me, to the left 4 units. Okay, then I'd go to my second dot. I know that this describes a vertical shift. The function is vertically shifted down, it tells the truth, 9 units. And you're writing that down in the second dot. Okay, now 1/2, if there's a value up front, we have to know, is that value greater than 1 or is it between 0 and 1? And 0.5 is between 0 to 1, so I'm going to use the word compressed. It's flattened out. The function is compressed by a factor of 1/2, or you could say 0.5. Let's look at the next example. All right, our third example, let's start here on the inside. The inside is always the horizontal shift if it exists. So in the first dot, I would write down here, the function is horizontally shifted to the right, because it lies to me, to the right 8 units. Now there's no number in back, so I don't have to worry about talking about a vertical shift. If I wanted to write it, I could put there is no vertical shift. You can ignore this if there's no number in back. 0.3, well 0.3 is between 0 and 1, so the function is compressed. It's flattened out. The function is compressed by a factor of 0.3. There should only be 2 dots on this particular. And example number 4, 2 more examples after this. Now this is where it changes. There is something here I need to speak about, something here, and something here. Notice there's no number on the inside. So I get to ignore the horizontal shift because 1 doesn't exist. There's no number with the x. There's not like an x plus 1 or x minus 3. I get to ignore this first statement. There is a number in back, and remember it lies to us, or sorry, it tells the truth. The function is vertically shifted down 7 units. Writing that out for the first bullet point. These are 2 separate things. These are 2 separate things, and we're going to talk about that next. The first thing is I'm going to take 3 divided by 5, and I get 0.6. 0.6. Okay, so because 0.6 is between 0 to 1, we're going to say the function is compressed by a factor of, and don't say negative, this is separate, is compressed by a factor of 3/5, or you could say by a factor of 0.6. This negative sign means that that V shape that we talked about, and we can see this graph right here, this V shape is going to flip down like we see in the green. So I need to write, and my third bullet point needs to be the function is reflected across the x-axis. The x-axis reflected across, so it went from going up to reflecting straight down. Let's look at the fifth. 4 different things we got to talk about here. The first one is I do see a horizontal shift. So I'm going to write down in that first bullet point, the function is horizontally shifted to the left 3 units. All right, done with that. The function is vertically shifted, it tells the truth, down 5 units. These are 2 separate things. First, I'm going to take 4 divided by 3 and find out, is that value up front greater than or less than 1? And I can see it's greater than 1, 1.3 repeating. So when it's greater than 1, I use the word stretched. The function is stretched by a factor of 4/3. Don't say negative 4/3, simply 4/3. And lastly, whenever there's a negative sign out front, it means the function is reflected across the x-axis. On to our final example here, involves decimals. And let's get started here. We do have a horizontal shift. So the function is horizontally shifted to the, it lies to us, to the right 9 units. Okay, it tells the truth. The function is shifted up 6 units. This value is greater than 1. 2.8 is greater than 1, so the function is stretched by a factor of 2.8. There's no negative sign in front, so I don't have to worry about addressing the function reflecting across the x-axis. I only have 3 dots for this particular. Over here to our worksheet, I would like you to make 3 dots because there's 3 things that you are going to make statements about up above. You can do that later. This will have 4 statements, so make 4. You can go back later. Let's go down below. There's only going to be 2 dots in problem 3. And in problem 4, I want you to make 3 dots. All right, you're going to go back and answer those in a little. The back side is going to be about writing equations. And we've already done that, but we definitely need to practice. And so they're all related to absolute values. So let me zoom in here. And so we're going to come up with the equation of this. So the very first thing we're going to do is we're going to go, all right, to get to this point, I had to go 2 to the right. Now it lies to me, so instead of doing plus 2, it's going to be minus 2. And then I have to go up 1, 2, 3, and it tells the truth. So I've got those done. Now, in this position, I'm going to put numbers in here. And so from your point, we're going to go rise up 1, right 1, rise up 1, right 1, rise up 1, right. So up 1, right 1, and this will be the equation for this example. Let's look at this one. Okay, so to get to this point, I have to go 1 to the left. Now I need to lie on the inside, so sorry, that's supposed to be an x. So instead of x minus 1, it's going to be x plus 1 because it lies. And then I'm going to drop down 1. So I have to the left 1, lies, tells the truth by going down. Now I'm going to make my boxes. And in this position here, I need to go from this dot to this dot. So rise over run. 1, 2, 3. I went down 3 and right 1. 1, 2, 3. Down 3, right 1. Down 3, right 1. And this is the equation. Okay, now I'd like you to flip to the back side. Here's where you're going to write the equation for problems 5, 6, 7, and 8. At this time, I'd like you to complete problems 1 through 8. Make sure it says your first and last name along with period 3 at the top. When you're done, please bring it up to the sub. Thank you.